Hi, welcome to PhyLab application. In this tutorial, we will be looking at how to meet a bridge experiment on our PhyLab application. From the home page, go to Meet a Bridge card and select Simulator button. It will start simulator for you. So, the first thing which will be greeted with is a dialog box, which is aim of the experiment. That says to determine the resistance of the given wire and also to see and verify the series and parallel resistor loss. Okay. So after closing the dialog box, we will be greeted with a schema diagram and we need to prepare the circuit as per the diagram. We can use zoom in, zoom out buttons and plus to create a new wire, and click on the wire one end that will be highlighted and the other end where you want to connect it to it. The first one is L1 and then I can zoom in. After that I can move the camera so that I can connect to the battery. The other end. Yes. And again I will zoom out, create a new wire and connect one end of the wire to the other end of the battery and zoom out. The other end of the wire connected to key, one end of the key. Again zoom out, add a new wire and select one end of the wire and connect it to meter bridge L2 and select the other end of the wire and connect to other end of the key. So the basic one diagram is done. And we need to close the bridge between two wire gaps G1. So first I will close the gap G2 which is connected to a resistor box. I will take two wires, one to connect to resistor box, and after that I will create a unknown wire and then connect the G1 gap. That will be my unknown wire. I need to find out the resistance of that wire. So that is the aim for the first part. And I create a new wire and connect it to jockey key and then one end to galvanometer and another new wire connect to other end of the galvanometer and then to jockey. So that's it. Our circuit is done. Click on the submit button. It will verify. And then the first thing is find the resistance of the given wire if everything is right. So now select the 10 ohms. Click on the 10 ohms button. It will be removed from the groove so that 10 ohms is applied in the resistance box. So on the left top right corner you can see the schema of the resistance box keys. Select the 10 key now. It will be removed from the groove like that. Next submit. 10 ohms is the applied. Submit and then power on the battery. Next move the jockey on the wire meter bridge so that the galvanometer reading notes as 0. It means that is the balancing point. So enter the distance where the jockey is from the unknown. Now currently unknown value is on left side, so that's why we directly give the value. Next is 15 ohms. Remove the 5. 10 is already removed, so 5. 10 plus 5 is 15. Again power on the battery. Move the jockey till galvanometer reading is 0 and then click on the submission dialog observations button and submit the value, that is 47.5 centimeters. Again power of the battery, make the 20 ohms, place 10 and 5 again and only select the 20 button, so that will be 20 ohms. Submit 20 ohms. Next power on the battery, move the jockey and enter the values. Power of the battery and set the 25 ohms. Sorry, not 25 ohms. Next is verifying the series connections. Series connection is like two resistances connected in series. Next, start with 10 ohms. The same procedure we need to do. Power on the battery, move the jockey till galvanometer reading shows 0 deflection. Enter the length, that is 74.3. Next, power of the battery, enter 15 ohms. 10 is already removed and 5 is removed. Enter the 15, submit. Power on the battery, move the jockey till galvanometer shows 0 deflection and enter the distance, that is 66.5. Next, power of the battery and 20 ohms, enter the 20 ohms. Power on the battery, move the jockey till the galvanometer is 0 deflection, enter the value 59.7. Next is parallel connection. So two resistors are connected in parallel. Again we will repeat. For 10 ohms, set the 10 ohms, submit the 10 ohms, power on the battery, move the jockey till the galvanometer deflection is 0, and then enter the distance, that is 42.4. Next, power of the battery, now 15 ohms. Power on the battery, move the jockey till the galvanometer deflection is 0. $32.9. That's it. Power of the battery. Again. Again the same experiment. Find the balancing point. Find it to be 26.7. Power of the battery. That's it. So once you took all the values, you will be greeted with the calculations page where we will be calculating the values. Next, let me open calculator because I am poor at mathematics. So L2 values we will be calculating for each L1 value. L2 value will be 100 minus L1. And then X value. X is our unknown resistance. The formula is R into L2 by L1. So we will calculate for each 3 readings. So let's calculate for third one. So R into L1 by L2, that is 13.89. Done. So the average resistance of the wire. Sum all the 3 resistance we found and divided by 3 because we have only 3 observations. We'll get the final average resistance of the wire. Next we need to calculate the specific resistance of the wire. We gave the length and the radius of the wire, and by using that we will calculate the specific resistance of the wire. That will be 0.108. Yeah. So next we will be verifying parallel connection or series connection, and then after series connection. So again the same formula we will be using. Finding out the L2 and then finding out the resultant resistance. And lastly, we will be calculating the average net resistance. 100 minus 66.5, 29.78 is the resistance. So the final reading will calculate final resistance, that will be 29.5. Now the average net series resistance. This is the series resistance when the resistors are connected in series. Sum all the three net resistances and divided by 3 because we have only 3 observations. So that will be 29 point something. So after that we will calculate for parallel resistance. Let's calculate for parallel resistance. This is where we took observations when two resistors are connected in parallel. So the final third reading for net parallel resistance. Yes, after that we will be calculating average net parallel resistance. This is summing all the net resistances and divided by 3 because we have only 3 observations. Then after that we will be calculating actual R1 and R2 by using the formulas. The net series resistance and net parallel resistance by substituting in the given formulas we will be the actual R1 and R2. The square root is 1.176. Next ours is plus 1.176 divided by 2. That is 15.29. And after that R2. R2 again minus 1.176 divided by 2, 14.114. So these are the R1, R2, actual R1, R2 values. Once you have done all the calculations, you click submit button. It will validate all your data, all your findings, and if they are matching with the simulated values, then it will upload all your data to cloud. If it is not matching, then you need to redo the experiment from the beginning. So that's the good of it. And once it is done, go to the home page. Here again open the MeterBridge. The download button is enabled for you. Click on that. It will prepare a PDF report and it will download that PDF report. And you can use this PDF report to tell your teacher that you completed this experiment successfully. Let's wait till it generates the PDF report. Yes, it got generated and downloaded. So open the PDF report. Zoom in a bit. Here you will see all the values which you observed in your experiment in a PDF page. So all your values here. So you can use it as you like. So this is how we can perform MeterBridge experiment using PhyLab application. Thank you.